This government meeting is brought to you by Eastworks and our local cable subscribers.
It is 6:02 p.m. It is January 22nd. This is a joint meeting of the Easthampton Affordable and Fair Housing Partnership and the Aquifer Protection Committee. Is anyone here for public speak? No? All right. Well, then I guess we can just dive in. Oh, here's Beth. All right, I think I think since there's nobody here for public speak, I think we can just dive into the presentation.
Awesome. So, all right, I'm going to take my computer so I can change the slides. So, sit. Okay. Switch chairs? No, I don't want to sit.
Professor.
Is there any way to get that full screen?
That is as full screen, I think, as I can get it. I think.
Try it.
I pinned it so it's the biggest one. Oh,
there we
bigger?
go. Yeah,
That's good.
Okay.
That's good.
Thank you.
Yeah.
Okay, so what I wanted to do tonight is sort of run through a little bit about the aquifer, how it formed. I'm a geologist, can't help it. How it formed, and by knowing how it formed, we can make predictions about where recharge may be occurring and how water flows through the system. So there is a reason why knowing something about how it formed is important. And then I want to talk about the information we have about the aquifer and where recharge occurs. All right. And to start out with, here's the Barnes Aquifer. And I want to point out a few things about it that you may or may not know. And the aquifer is shown in yellow here. And we'll say there are three parts to it that operate as essentially three independent systems. And of course, the first is the, we'll call the Broad Brook part of the aquifer. Broad Brook is the river that runs south and turns around and flows north. And it marks this side of the aquifer. The aquifer is made up of superficial sediments, that is sands and gravels that were deposited during the retreat of the last glaciation. This part is defined by a groundwater divide that's located about here, just north of the Camden Ponds. And north of that divide, the groundwater flows to the north. South of that divide, it flows to the south. So those are two sort of independent systems. And then we have the third system over here, which is sort of the Manhan River side, Southampton side. And again, there's a groundwater divide down here somewhere that separates water going to the south from water going to the north. And when you get down to here, these two sides come together and the water eventually goes out and it gets to the Connecticut River somehow, either into the Oxbow or under the Oxbow and into the river. So this part of the water goes this way. The red dots represent the municipal wells. Maloney Well, which is not being used, Nonotuck Park, Brook Street, the Pines Well, and the Nonotuck and the Hendrick Street well field. Okay, so those are Easthampton's wells. This is Southampton's one well, and then Westfield has a series of wells down here. But again, this is an independent system than this, and which is separate from this. Okay, so 3 different components. The red hatched areas represents the EPA designated sole source aquifer. And you know, you might say, well, gosh, Bob, the aquifer is in yellow and this sole source thing goes beyond the aquifer. And that's because they protect or they designate the secondary recharge areas. So any water that falls here is going to run eventually into the aquifer. So that was included in this sole source designation. Okay, the other thing I want to say is if you have any questions, shout them out. Don't raise your hand, just shout them out.
Where's Mount Tom in that map?
Mount Tom is right here.
And that water goes down into.
On this side, yes. On that side, no.
Is there a similar red hash mark area for the other wells?
No,
No.
no. The
So not for
EPA
Southampton.
Oh, I think you touched it. Hold on.
I
I
did
don't
touch
know.
it.
I don't know.
I'm guilty. I admit it. I can't touch it.
It's news to me. Oh, it's somehow stopped sharing. I can see you, Bob, but I can't see your presentation anymore.
Okay, my technology died. So. I mean, I guess, am I out of the meeting?
You are.
You're there. We see you.
Middle box.
If I do this, does that show?
No, I think you have to restart your screen sharing.
Yeah, I was just gonna say, if you go back into the meeting page, yeah. To the web browser where you're logged into the meeting. There it is. It just shares.
So don't give that.
That's why you get bucks. Just. It's not overly. That's why she deserves. Yeah. There you go. You make that big again.
Well, yes, once,
I have to do that.
yes. And then I can pin it. Oops, I unpinned it. Sorry. And
The bottom right corner of his little,
right there.
but a little bit to the right, I think.
Yeah.
Oh, here. I don't know why it defaults to Rachel. Okay.
Good team member right there.
So the trick is I can't touch the screen.
I don't know. I guess maybe don't try
Don't
not to touch
the screen.
I'm not 100% sure that was the problem, but
Well, we'll blame that.
Yeah.
All right. So I want to talk a little bit about how the aquifer formed, and it is it's kind of an interesting story. But anyways, it was formed during the retreat of the last glacial ice. You know, about we'll say 14,000 years ago, roughly. And when the ice is retreating and melting, then tremendous amounts of meltwater come out from the glaciers, and they're carrying lots of the water. The rivers are carrying lots of sediment, and that sediment is sorted by the rivers. So there's a glacier right behind us, and you can see the whole valley from side to side is completely filled with this gravel, and this is these boulders are about this size, and you can see it makes for a sediment that has a lot of pore space. So if it's sorted, you have nice pore spaces like this, and this is going to be your aquifer. So your aquifer material is the pore spaces in the sand and gravel. And if you go out and look at gravel pits, that is the aquifer. And in this case, there are layers of gravel and layers of sand. It's well stratified back and forth. And, but this is what the aquifer would look like. There's also finer grain sediments, because when the ice was retreating, there's lots of lakes that formed. And as you probably know, there was a glacial lake that extended from about Hartford, Connecticut, in the Connecticut River Valley, north to St. Johnsbury in Vermont. So a very narrow, very long lake, Glacial Lake Hitchcock. And the fine sediments that are in suspension in the rivers all end up in the lakes. And they sit in the water column and they slowly settle out, especially in the winter when the lake is frozen over. That fine grain settles out. And so the clay layers here are winter deposits, and these layers are summer deposits, and that's 1 year in the period of the lake. But these layers don't have very high permeability, and they tend to block the flow of water. Water goes through it, but very slowly and not very much. So the glacial lake sediments are going to be generally impermeable, and where the sand and gravels are permeable. And there are other glacial sediments that are even more interesting, but we can't talk about those. Those are things deposited directly by the glacial lakes. So let's imagine that the glacier's sitting here retreating in the valley, and when the glacier, it's not always retreating. For some time, it will stay in one place, but the ice is always moving this way, but it's melting, and so it could be melting back at the same rate that it's moving forward, in which case the ice front would stay in one place. And when it's retreating, the ice doesn't turn around and flow back to the north. It just means it's melting faster than it's being replenished. So there were pauses in the retreat of the ice. And during those pauses, the meltwater streams that were dumping sediment into the lakes, that sediment just accumulated at the ice front. The coarser stuff, the sand and gravel, formed right at the front of the glacier, accumulated there, creating these deltas that were built right next to the ice. And then the lake extended off to the side. So now we look at some later time. The ice has started to melt faster than it was being replenished here. And so, you know, it's moved back from there to here. There's still meltwater pouring out underneath the glacier, depositing sediments, sands and gravels, those nice, well-sorted sands and gravels at the bottom of the lake. But it doesn't sit there, the front doesn't sit there long enough to build it up to form a delta. And so it just keeps melting back. So it melts back. The lake, of course, is still here, and that lake is being filled all the time by the fine sediments that were in those streams. And so even though the ice front is way back here, there's still lots of sediment coming out of the water column, but it's now the clays and the fine sands to form those varve clays. And they sit on top of the sand and gravel that is built up to here. So if we look at this area right here. So we're going to look at a diagram right here. And we'd say, well, what's that going to be? We're going to have clay, the bar clays, that annual deposits that were forming directly from lake deposition, sitting on top of sands and gravels right here. But of course, when the ice had paused at this point, the sand and gravel goes all the way to the surface. So clearly we can sit here and say, okay, there's a recharge area right here. The aquifer is exposed at the surface of the earth right here. This is where recharge is occurring. Okay, you're not going to get much recharge over here because of the clay.
Can you define what you mean by recharge?
So groundwater is flowing and it has to be replenished to continue to flow. So in these areas, when you have rain events or snow melt events, water infiltrates into the ground and will go down and recharge the groundwater. So if you get, in the summer, there's not much recharge, even if it rains a lot, because there's so much soil moisture deficiency because the trees are sucking all the water out. But once you reach what's called field capacity in the soil, beyond that, then the capillary tension that tends to hold the water in these pores is overcome by gravity, and the water starts to fall down, move down as little droplets that come down and recharge.
And that goes into the sand aquifer, or it just starts to flow back down?
It goes down. It's even in the aquifer here, but it's unsaturated part of the aquifer. There's still water there, but it's unsaturated. And it will, once you've reached that amount of water in the soil. I touched the screen.
I guess that wasn't it.
Damn. So, and the other thing I wonder about was, did my
Fall asleep?
fall asleep? Yeah. Okay. So it comes down and it hits the water table and it fills the voids. It causes the water table to rise, and then water, of course, is always flowing this way, and that's causing the water table to go back down. So the water table goes up and down. Recharge brings it up, and then when it's not raining, it goes down, and all the time that water is moving towards a discharge point, which is going to be the rivers and streams. Okay? And the water that falls here, the pore spaces are so small, it can't overcome the capillary tension that's holding the water. So there's not enough gravitational to pull it down. So it just gets stuck in here, and you can saturate the clay and you won't get any water moving down through it. You get a little bit, but not significant amounts. If you drill a well here, you drill down through the sand and then you hit water, and if you drill down a little bit further, then the water is in the water, it's in the level of the water in the well is what we call the water table. It's the boundary between the saturated zone and the unsaturated zone. Okay, that's the water table. When you get over here, if you drill a well here, what will happen is the well will be dry until you break through the bottom of the clay into the aquifer, at which time the water level in the well will rise up. And so this dashed line here is kind of a theoretical surface. It's the level to which water will rise in a well, if you were to put the well there. And this, what's called a potentiometric surface, this pressure surface, can actually be above ground level, in which case you drill into it and you hit water and the water comes out of the well and you don't need a pump. We have those wells now. And this is one. This is an observation well near the Bologna well at the north end of town. And there's been a hole drilled in the top of the tap, and the water sprays out continuously because the potentiometric surface here is above ground level. Here is a place where there can be no recharge at all. no matter what, because anything, any water that gets into the falls on the ground, the groundwater is coming up. It's not you can't overcome the water coming down unless you were to put the water depth above the potentiometric surface. So you can see how this could occur. Have these deltas, then you have high level deltas, and you get lower levels. And so you can get a situation where the potentiometric surface is above ground level, and we have that here at the moment. Okay. So for us tonight, we're most interested in recharge. Where are those recharge areas? We don't want to cover them up with impermeable surfaces because that's how we get our groundwater. So that's our most important. So how should we go about figuring out where recharges occur? Of course, we look at geologic maps. So this is let's call this official, it's really not, but I'll call it a superficial geologic map where you map the surface deposits, not the bedrock, not the nice red rocks that we have here, but instead you map the sands and gravels and the glacial lake sediments and the glacial till, all those different materials. And in this map, the blue represents the lake bottom deposits. And the orangey color here represents the sands and gravels where they're exposed at the surface. So this is aquifer exposed at the surface. And from what you've heard tonight, hopefully you would understand that it's likely that the sand and gravel here extends underneath a lot of this clay area. Not everywhere, but that's something we would tend to expect. And we wouldn't be surprised if that were the case. And then the yellow is just recent sediments from the rivers. Okay, so that's the map. And it's like the most important thing that we have to go on right now about where recharge is occurring, because we would say, well, where the clay is, then we don't have to worry about so much about recharge. That's not where major recharge is. It's these areas we want to be most concerned about.
Which ones, the orange ones?
Yeah, because that's where the aquifer is exposed at the surface. Okay, so that's the really critical area. So now the bad news. So this map, which came out in 2018, it's done by Janet Stone and Mary Giacomo Cohen. It's a great map, well done. It's a compilation. They didn't do any field work. They did a little bit of field work. They didn't do field work the way a geologist would normally go out and map a quadrangle. This quadrangle has not been mapped. In the little corner here, it references how they did this. The map units were reproduced from Larson 1976, unpublished field map. Well, I hate to say this, but in 1976, I was a graduate student at UMass. And Fred Larson was one of my colleagues. So I pretty much know what he was doing. We were both doing glacial geology. And he did great work, but he was not mapping this quadrangle in the way, I shouldn't say that because I think for a while he kind of was, but then he didn't. So anyways, this is not a well-mapped quadrangle. So when we look at these blue areas, there are mistakes. That's a big problem. And I know there are mistakes because my house is right here in the blue area. And I can guarantee you that it's all sand. As I've checked.
So if I'm on Mass Mapper, when I'm looking at like the soil classifications, it's not based on this, is it?
No. Although the
That's
soils
just
people
like-
have, the soils people have really mapped it.
Okay, all right, that's reassuring.
Yeah, I will say that.
there still federal money to be mapping?
Mapping is dead. I think, but I want to be very clear about this. This is a beautiful map. It was done
It's
the
imperfect.
best it could be done under the circumstances. But it's not perfect, and that's troubling. I'll put the next map. So this is the map to the south. So that was the Easthampton quad. This is the Mount Tom quad. And again, based only on Fred's work. Now, actually, Fred did a better job here. I'm not sure, he might have, no, I don't, it wasn't published, it was never published. But this was a little bit better done. But here for us tonight, the big problem is we are gravitating towards this boundary between the what's mapped as clay and what's mapped as sand and gravel. Okay, in some places it's probably correct, but not everywhere. So
For
Yeah.
those of you who can't see that and are bad like I am, that's Plain Street that he just pointed to.
Which one is Plains?
That is Plain, right, that's Plain Street.
this is Pomeroy Street.
Yeah. You need a little orientation, because I'm often bad at.
Where's Hendrick Street? That'll help us too.
Hendrick Street is here.
Perfect, thank you.
Comes down like this. At south end of town, this is the Plains area. And I put this in here because that's not how it looks today.
No.
That's how it looked in 1972.
So is the problem with the map is that it wasn't done accurately, or is that the ground has changed?
Oh, no, it hasn't changed. No,
Hasn't changed.
hasn't.
Okay,
There have been changes,
Somewhat
yes.
incomplete.
okay.
Now we have more information.
There are some things you can't see, it's too small. These little brown things, those are artificial fill, and that's because we've changed it. But the rest of it is glacial sediments that aren't going to change in our lifetime, unless somebody mines it all out. So that's how it works. Now, I'm going to take you on a little fly through. I think this will work. This is. Stop it. So we're gonna do a little fly through, and so I've taken the blue lake unit and I've superimposed it on the digital elevation model, and also the yellow sand, aquifer exposed to the surface is here. So the blue tint areas are where there's lake sediments. The other one is where there isn't. And so we're going to take a little flight. So this is, to get you oriented, this is 91 right here. This is the Oxbow, and this is the Connecticut River. This is Mount Tom. And hopefully you'll be able to sort of see. Screen doesn't quite have the resolution I would like, but we'll see. No, don't do that. We'll just go.
Coming from the north?
We're coming from the north, going south. There's Mount Tom, and here's the center of town.
All the mills
Yeah,
right
those
there.
are the mills there, and the pond. And we're right here in this building right there. And we're gonna turn and go south. There's 141, the mountain road. So here's the Plains area. This is the 1983, not 1983, 2023 air photo. So I think that's the most recent orthos. And this is Pomeroy Street, which we can say is sort of the end of Easthampton. And we're now in the yellow zone. This is how much we've developed the yellow zone at this point. We've got a lot of houses there. And as we go further south, no. Well, a little review never hurt. So Oxbow, second Oxbow, older one. There are the factories. Here we are right here. We're all in the blue here, so we're still in the lake sediments. What's mapped as lake sediment. Here's the boundary right there. We're now into where the aquifer's exposed to the surface. Pomeroy Street, which is sort of the end of town. Now we're in Southampton and Holyoke. And then we get to about here. This is about the end of the aquifer right here. Our section of the aquifer. Hamden Ponds and that way is in the Westfield part. So many years ago, my students did a project where they did housing density and how it might be impacting recharge. So here's the Easthampton part of the aquifer. That's actually not the aquifer directly, it's the zone 2. And zone 2s are the areas that contribute water directly to the municipal wells. 180 day, I think it's 180 days. Good.
And dry
So
conditions.
that's what the zone 2 is. And Patty, is it true that that's basically how these things are decided in terms of whether you're in the zone 2 or not? Is that used for like zoning?
Yeah.
Okay, so I don't like that because we just talked about the fact that the aquifer could be covered in clay in some places. So that's a problem, I think, from our perspective of trying to get more housing. And, do we just want to blindly protect all the zone 2s? Well, this is the zone 2 for, wells. Okay, I've got the old well there. But anyways, you can see here are the wells, town wells. Here's the housing density. A lot of houses here. Why are there a lot of houses here? Because it's the surface of a delta. It's flat. It's all sand. Percolation. Tremendous percolation. Of course, that's horrible. Don't put houses where the percolation rate's really, really high because that's where recharge is occurring. But anyways, we can't fight history. And now if we...
But that area where.
No,
They could have their own house.
they certainly could have, but that's not, it's all town water. And initially, it was sewers, it was septic tanks, but now it's all sewer.
And so when those houses were built, planes were built, the Aquifer Overlay District did not exist or did exist?
Or
Not as,
1990 was when it was.
okay. So these houses were all built before the Overlay District was enacted?
Some of
Or a
Because they
lot of
started
them.
building over there in the 60s.
Yeah.
Because
Yeah.
the house I'm in was built in 66. It was one of the first houses, so.
Yeah.
Okay.
Yeah, and I think the zoning initially out there was R14, and then they changed it to R40 after the Mott study. Is that true?
For a while, it wasn't zoned. And
Even
then-
better.
Yeah, right. I'd have to look.
Okay, but so this. Anyways, if we now take the zone 2 and we put the blue clay layer on, we say, oh, look, this area is zone 2, but if it really has clay on top of it, do we need to protect as much there as we do here? And I would argue, touching the screen, that I would argue that, you know, you need to maximum your protection here. And you can perhaps think that you don't need quite as much protection here.
Do you know what streets those are? They're the purple area. The purple area.
What's the,
Like, what are the streets there in the purple area, the border streets? Do you know?
so this is Hendrick Street.
Okay,
Plain Street is here.
okay, so Plains kind of a little bit the border, like loosely.
Yeah.
Okay.
And, you know, even looking at this, you can see there's many more houses here than there are here. Because, well, yeah, the percolation rate was much higher here. This is much better to develop here than here. And of course, this is closer to the wells. But do we have to, if we were next to the Maloney well, I know the town is considering or has eliminated the Maloney well, but that's a bad idea. But anyways, the thing about that, if you were to put, that's bad, you're gonna yell at me, but if there was waste put next to the well, it couldn't contaminate because the water's moving up,
Got it.
right?
Yeah, like it's that
So
little spit
anything-
thing you were showing.
Yeah,
us.
exactly.
Got it.
Now, in fact, it's more complicated than that. And I don't want you to go away thinking that that's exactly true. But I don't want to go into the geologic story. I do want to go into the geologic story, but you don't want me to. But there is some complexity. And I think that's what I would like you to know. That there is complexity here. Not all areas should be treated the same. And if you put the zone 2 of the Maloney well, it would go all over town, right? And we know there's clay there. So it's not the same as this area. So we have to pay attention to what the geologic story is. Okay, and then I want to say something about Sustainable Water Management Initiative. We go back to 2012, which for me was like yesterday, but for you was probably a lifetime ago.
Can I ask a question about the clay layer? So in the years that we've worked together, I've heard you talk about that the clay layer is different thicknesses. In some places, there might be holes in it.
Yes.
So what happens in those holes? Is there still that sort of pressure upward that would, okay.
Well, but that's exactly the case in the Maloney well, because there is a brownfield site, you know, the factories dumped all their stuff out behind the Ferry Street factories, right? So it's a big waste site out there. Right. In my younger days, I could actually throw a stone to the Maloney well from that site. And so as long as the potentiometric surface is above ground level, that stuff can't go down. The problem is, if you start pumping the Maloney well, what do you do to the potentiometric surface? It goes down. It goes down a lot. Confined aquifers and unconfined aquifers, like they're totally different beasts. And the change in head causes you to have big changes in that level. So, but that is, in that site, there's a hole in the clay, and there's a hole. I won't.
Sounds like a song.
I'd love to be able to tell you the story of eskers and why there are holes in the clay. But at the Maloney well, yeah.
So, can you tell me where that is?
Yeah. Let's go back.
And it's no longer being used by the towns.
It's not being used, and they want to terminate it,
Which you think is a bad idea.
which I think is a bad idea. You never want to terminate a well that you've got permitted. It's right up here. Okay, so on the map, to get you oriented, these are this is Ferry Street would be right here. Okay. And so it's the factories are here, and then you have the Manhan, and the Baloney Well is on the north side of the Manhan River as it flows behind the factories towards the sewage treatment plant. So down in that area.
Off the bike trail.
Off the bike trail, right behind, beyond the bike trail.
That little building, it's like a little building back there. It's kind of as you go, as you cross. So there's the Ferry Street Circle. You go past there, go up a little ways and there's a little road.
There's a
left field, but before you get to left field,
there's a little building with a sewer treatment, sewer pump.
Yeah.
And the well pump is back in the
Okay.
back off there. You can't see it from the road. And so if we go ahead and just so keep this in mind, and we go to here, I'm going to stop this. Or I'll go to the next slide. One or the other. I just have to make sure I press this. So if we get to about here, so I believe the Maloney Well's about right there. And it's all in this blue.
And where's the Ferry Street project? Oh yeah, I see the.
So this is the Ferry Street project, and this is all the buildings on Ferry Street there. And these factories had their own well field. They had a very extensive system of wells all through this area here, and their waste extends all in this area. So we have a lot of information from in here, and the reason why they put wells there is that there were springs coming up out of the ground. They could see that. And the reason why there were springs coming up out of the ground was there was a hole in the clay. All right, let's just quickly go through Sylvia's last thing. And so how do aquifers relate to rivers? And of course, rivers get their water from the groundwater. When it rains, of course, there's runoff that goes into the rivers, but if it hasn't rained for 3 weeks in the summer, the rivers are still, most of the bigger rivers are all still flowing. Where are they getting their water from? Well, they're getting it from groundwater. So the big discharge for groundwater is to rivers. And the base flow of the river is determined by the amount of groundwater in the area. So our aquifer is putting water into the river system. And historically, about this time anyway, there was concern about what pumping groundwater was doing to surface water. And I use the example of the Ipswich River up here. I grew up right next to the Ipswich River in the town of Linfield. And used to fish as a kid, I'd ride my bike to the Ipswich River and go fishing. But then the Ipswich River dried up because they were pumping too much of the groundwater in the watershed. And they actually dried up the river in the summer. It's like the Manhan. Imagine drying the Manhan. It was about equivalent to that, maybe even a little bigger than the Manhan. The state started looking at groundwater withdrawals and how it was impacting rivers. And so they did this Sustainable Water Management Initiative, and they looked at a number of things. but they're basically looking at how much water can you take out without impacting the streams and in a negative way. And so they did this analysis, and they targeted areas to say, look, you know, not areas the same around Boston as you might expect. That they had this groundwater withdrawal category where in August they were altering the flow of the river by greater than 55%, reducing it greater than 55%. And they said that's bad. So we're going to flag those aquifers that are being overpumped, and you know, they created this map. So as you'd expect around Boston, yes, but some of Western Mass, yes, and here we are in Easthampton, and we are in the one of these high impact areas. My initial response was I didn't believe it, because hey, there's clay, right? So, you know, how can, if there's clay, how can it do it? So anyways, with Mike's help, I had my students do a little experiment. And so this is the Hedrick Street well field, and Broad Brook is right here in the brush line there, going around there. So Broad Brook is right next to the Hedrick Street well field. And what we did was we drove, we put in a piezometer, which is simply an open pipe. And we drove it in to the bottom of the stream with a sledgehammer. And then we put a device in to monitor the water level. At the same time, we put a device to measure the water level of the pond. And then, so here, this was in 2013, and we collected some data. And what we found was that the piezometer is sort of showing you the impact on the groundwater. And you can see it, you know, it's here and it drops here, but that's the blue line. Here, drops here, back up here, and then bouncing all around. Well, this is the pumping of the well field. Whenever you turn the pumps on, the water level dropped in the piezometer. And the red line is the stream. It also dropped in the stream. So you can see that the pumping of the well at that site directly impacted the amount of water flowing in the stream. You can't deny that. I mean, it's not very much. You know, it looks great. It looks like a big change, but of course, this is 3.90 feet. This is 3.95 feet. So you're reducing the water level of the stream by no more than 0.05. And so what does that mean?
Do we know how many gallons a day that well was pumping in 2013?
Well, we do know. I'm sure it's in the report that my students wrote.
My guess it's pumping a little bit more now because
I don't think so. I don't think it's significantly different.
Actually, the flows in 2013 were a lot higher than they are now. That was just before we had the big leak and under the.
Yeah, because I remember I looked at the data.
Because that happened in February of 14.
Right, because I looked at the data to see if we could see where that leak was.
And you can't.
Yeah. So anyways, so there's something to swimming, but maybe we can get Mike to say something about what's wrong with swimming analysis. But I'll just sort of summarize by saying, so yeah, swimming says we're hurting the aquifer, even though in the past we pumped 6 billion gallons a day, and now we're pumping like 1. Don't know what the impacts were back then on the streams, but anyways, it's something for us to consider. I don't think swimming is necessarily going to prove to be telling us that we're in a terrible situation, but we need to pay attention to it, is all I'm saying. And I'm unfortunately going to argue that we need more information before we go too far. We need to know where the clay really is. I think, and then I would say we need to look at zone twos through a different lens. Not that all zone twos are equal. There are some parts of the zone two we really have to pay attention to. Other parts, we might have other things. But that's basically it. So I'm happy to answer any questions. Yeah.
Yeah, so great presentation. I just want to thank you for the detail, and I'm also a little bit of a nerd, so I enjoy like the detailed explanation.
I'm a nerd.
Just kidding. I guess I'm curious how the patterns that we can expect with a changing climate would impact some of these things. Like,
Yeah.
like some of the questions that I asked during our last meeting about, you know, rising groundwater measurements over time and increased precipitation levels. And I know Dr. Bout mentioned that a lot of communities are struggling with the idea that the ground is holding water in some places. So I wanted to hear like your take on that side of things.
Well, I haven't carefully studied that. I've talked to Dave quite a bit about some of the data because, you know, he's using a couple of our wells in up at our police station. I think it really is true that water levels are increasing in some areas. I don't know if I've seen anywhere where it's a problem, but how climate change is going to influence all this is something I don't think I'm prepared to say.
Which I think goes well with the we need more information.
Yeah.
Yeah.
And I think we're always going to be, I don't know if we'll ever be totally happy with the climate analysis. But I think it can help inform us about what kind of extreme, you know, because we need to be planning for the extreme cases, not the normal cases. So if we had a 1960s level drought, what would be the impact? We certainly should be looking at that. And it's absolutely true that the amount of total precipitation is increasing every year. I have stations at Smith that we have 25 years, you know, about 25 years of record on, and that they all show increasing precipitation. So that's a good thing. But is it increasing in a way that affects groundwater? Because a lot of those are extreme events and it all runs off. So I think it's a difficult question. You're probably up to it, but I'm not sure I am. Yeah.
Can you speak more to the more information we need? Like how, is there a path to getting that information? Is there a site-specific analysis you can do, or is it more like a?
So I'm going to say two
region?
things.
Yeah.
And the first thing is just because I'm old and cranky. And that is that the mapping program is dead. And it's a terrible thing. It really is. But for many different reasons, it's hard to get mapping done. I've been working with the state of New Hampshire, who's trying to maintain their superficial mapping program, and next year it's dead. It's dead because they don't have people to do it, but more importantly, they don't have the money. The money is dried up. So, all right. I mean, yeah, go ahead.
Just to follow up on that, is there any hope with like the groundwater atlas work that Dr. Bout is working on with the state?
Oh, yeah, I think that those kinds of things might get done. But I'm talking about basic mapping level stuff that isn't sexy. It's
going out there and taking cores and
actually mapping the deposits and walking everywhere. You know, now you can't get permission to go many places. You know, you can't get permission to go into gravel pits because they don't let us in anymore. You've been have trouble getting into the national forest this year, for political reasons. But, so that's kind of a negative thing. But there may be other ways to do it. There may be geophysical methods that could be employed that we could, because we talked to Dave, he suggested we get airborne electromag done. And the modern electromag has had a fair amount of success in mapping areas of clay.
So is that just like a big magnet strapped to a plane or a drone or something?
It's not a magnet, but it is a huge antenna. It's like 30 feet in diameter, and they suspend it from a helicopter and they just fly over the area and induce electric field and then see how it varies the magnetic field. And so I think something like that could potentially get done that would solve our problem. That would be what I would hope for. But I think, unfortunately, to get that done is going to require federal dollars. And I'm not sure it's possible.
Do you say that because of the amount or
Yeah, it's expensive.
like ballpark?
I think to do what we want to do, $500,000.
I'm curious about what happens with, so we had that major flood a year or two ago.
Yeah.
It wiped out a bunch of fields and
Yeah.
what happens to all that water? Does it go into
The ocean
the ground field or does it, like what,
River
where?
to the ocean.
goes to the ocean. Interestingly enough, and I'd have to look at my data, but I will say that almost those storms all occurred in July. Traditionally, we don't see any recharge in July. We don't see any, you can even, whatever happens in terms of rain. There's so much soil moisture deficiency. So the trees, once you go to the growing season, the trees are sucking huge amounts of water, and grass and everything that's growing is sucking huge amounts of water into the atmosphere. And the soils become depleted in water. So when it rains, the water that goes into the soil is sucked into the small capillary pores and held there by capillary tension.
Is there a way to counteract that with like artificial recharge methods that just like go right into the aquifer?
Yes. So yes, absolutely. But be careful because it goes directly into the aquifer. So if you put something bad in there, it goes. You're injecting it directly into the aquifer. So yeah.
Is that, well, in the case of when it's not the warm season, wouldn't that also be the case of just anything that's on top of that sand layer? Wouldn't that just go right down as well in a similar way?
Oh, no, because the soils, that organic matter is highly reactive.
Okay.
So it likes to grab things. It grabs metals, it takes VOCs, bacteria break them down. So that organic horizon is very, very important for those reasons.
So is the concern with adding impervious that you're also eliminating areas of that organic soil horizon?
Well, I would assume that so that's a really good question because it depends on what happens. You put impervious surface down, what happens to the water that falls on that impervious surface?
Yeah, it runs off somewhere, and ideally to the right place, not just to
But if
the,
it runs off in the stormwater
the catch
system,
basin,
it's
then-
gone.
yeah,
You're not
it's,
gonna get that. If it runs off into the grass,
right.
maybe it's seeing that enough of that organic layer to, so maybe design some kind of bio retention basin that's got recharge capabilities, and so you've got organic stuff, and it tends to purify some things. It won't purify some things as well, like salt will go right through it, but
I have a follow-up question just regarding what you said about that layer on top. So you mentioned there being concern about number of houses, but I guess I'm confused as to why that would can be a concern versus just recharge area or impervious surface alone being the concern.
So the houses was just done as a proxy for impermeable surface.
Okay.
So it was just, that if you've got roofs, they're impermeable. But maybe you don't have gutters and goes and drip on the sides and goes through a base. So it's hard to know. I mean, you still have losses because of evaporation stuff, but it was just a proxy for impervious surface.
Okay, so impervious surface is the main concern when we're talking about development. Like there's not anything about like if we have one house that is split into two houses, but it's on the same footprint, has the same amount of impervious surface, XYZ, is that adding to the level of concern?
So it does add to the level of concern in my mind, simply because there are more people and people use more stuff. So it's not just that it's impervious. You don't want to put chemicals in the system that are going to infiltrate.
Okay, and I guess that's where I'm confused because you mentioned that top layer being sort of protective in that way.
Yeah, I'm talking about a forest soil. Somebody's lawn is not a forest soil. They've taken all that forest soil, they've got rid of it. And so it's a totally different system. And if you put fertilizer on it, if you put Roundup on it or something, then you're talking really nasty things. So the more people you have, the more stuff gets into the system. I often go back to my misspent youth. And, back when I was a kid, we all got old cars, had a Jeep, and I rebuilt the engine. And so, I took all the parts and cleaned them with a degreaser. Then what did I do with the degreaser?
Dumped it in the woods.
I dumped it in the woods. I just went out. I wasn't even in the woods. It was on the grass. I just dumped it. So the more teenage boys in the 1960s that were around, the higher the proportion of contamination would likely occur. Someone should do a statistical study.
That'd be interesting. There were some girls who did that too.
That's good.
Mine was a VW.
So I think, impervious surface is easy for us to target. It's pretty straightforward. You can handle it. The chemical aspect is not so easy.
Yeah, and I mean, there's also a limit to how much policy can really influence that. Because I mean, we can't tell people they can't double up in a house or they can't have their kids live in their basement because they can't afford an apartment. So like, there's limited policy tools to limit the amount of people.
But with my groundwater, I'm not practical like you are. I don't have to deal with those real world problems. I can just come up and say, if you want to protect your recharge area, keep it forested. Don't let anybody in there. Just keep it a nice natural forest. That's the best thing you can do.
So what about if people were doing now you can do an ADU on your property. So what if you were to do an ADU on your property? It's going to be an impervious surface up on the roof, for whatever the small footprint is of the ADU. But what if those ADUs were built on blocks or something that left a space between the floor of the ADU and the ground underneath it? Would that still protect the
But you wouldn't have any recharge there.
because when it rained, the water wouldn't.
You'd have to
would
let the
never
water
get
go
under.
through your house, and I don't think.
I mean, if it was raised, so if the ground was here and the house was here, so there's this space here, then
It's still not hitting the ground
So
underneath the
now it's not
house.
gonna
it's not hitting the ground, but if you were, it's like a little bit of a hill.
No, and also-
So what you
I mean, I'm
could
just
do,
trying to think
I don't
creatively
think
about
building
how do
code
you.
would
but what you could potentially
How
do
could
is
you
to, if you didn't have any basement, you could build an infiltration system underneath your house.
Yeah, and I guess we could, I mean, there could also be other mitigating, if you're just trying to mitigate harm, you could, not have paved driveways, you could ask people you could not have lawns, you could have to have natural, I mean, there's just other, it's kind of like the low hanging fruit to just say like, you can't put a house, but if you could also, there's a lot of things happening there now with the people that live there in terms of pavement and chemicals, and there's other ways to mitigate harm, I guess, to the
So
aquifer.
what bothers me is, it takes time to see the impact. Might take 10, 15 years to see the impact. And maybe you won't really see the impact until you have a prolonged drought period or something. So, you can come up with creative ideas, but I'm not sure that you'll know if you're successful or not until it's too late.
It'll already be too late.
So I would just,
Say that.
I would try to emphasize the point,
Sorry.
there are some parts of recharge areas that we just should not.
No, I agree. I'm not arguing with that. Yeah, I'm just.
No,
thinking-
I think you're looking for solutions.
I'm not just saying like in place of, I'm just like, no, we should be considering these things anyway. Whether or not there's more housing, we should be considering other ways to mitigate harm to our aquifer.
Yeah, and where do we really stand? Because if Swimmy's right, we're already in trouble.
The overlay district that currently exists covers the zone 2 area, like what's the map of that district?
It doesn't cover the Maloney zone 2.
Okay, but it covers the Plains zone 2.
Yeah, that red area that we saw on that first map is basically
Like
also
the
the.
broad basin area. Yeah.
Okay, so that's the area where you're saying all zone 2s aren't the same.
Exactly.
And we,
The fact that you don't have the Maloney is not a problem to me because Maloney, for the most part, is protected.
And clay. Yeah.
and that northern part of that zone 2 that's above Plain Street, which is slightly bluer, I think, on your map, could be a part we could investigate in terms of like what is there for clay, because the southern part is the part that is really the most important to protect, which is like all
Yeah.
sand and gravel.
Yes.
So
Yes.
when you mentioned that your house, you knew it was sand when the map had shown clay, is that map that you said that is erroneous, did that at all inform the zone 2 boundaries?
No, well, I'd have to go back and check.
Does that-
I mean, the zone 2 boundaries were determined by a groundwater mathematical model that they ran. And it was to do the model correctly, you need to know the thickness of the aquifer and those kinds of things, which they would get from these maps. So it does influence it in some way, but
Like, is your house in the Aquifer Protection District?
No.
Yeah, that's what I mean.
but it's my house is on Main Street, so it's in the Southampton side of the aquifer.
Mm.
It's not in the Easthampton.
Okay.
So we don't protect
Well, yeah, no.
anything on that side.
Got it.
Don't, but doesn't mean we shouldn't.
I mean, that's the other thing is, what are you gonna do if some catastrophic thing happens and you lose half the aquifer on this side? Where are you gonna go for water?
That's why it's a sole source aquifer.
But I think you actually have potential on the Southampton side. We have a couple landfills out there, I think actually 3.
In Easthampton or on the
That's not a
Southampton
sole
side?
source, right?
On
Because there's at
the-
least
in
3
Easthampton.
wells.
Well, one's Northampton, but right on the
The
border.
ground.
So
Okay,
it's
yeah.
Northampton's old
Across from
one,
the same.
our old one, and then the old one, on
Loudville.
Loudville Road, yeah.
Yeah, Loudville and all of this.
So in planning, it probably makes sense to protect that area as well, if it's aquifer recharge.
Well, I think that's part of the question. I mean, I think, ideally, yes, of course, you
Yes.
should do that. But, let's take the extreme example. We have perfect aquifer, high yielding aquifer all underneath town. Would we ever use it all up? Well, maybe if we contaminated it, but if we could protect it, how much would we have to protect to ensure that we always had enough water for whatever the projected population of the town would be?
It's currently projected to shrink.
Yeah.
So,
Whatever,
Yeah.
I mean, whatever you project, you need to have enough for that. And it's, we know we're in a pretty good space because, 6 billion gallons, we know we've done that. It might not have been sustainable in the long run, but we did it at least for a little while. So I don't know, there's a lot to think about.
So your suggestion is that we need more information, and part of what we need is to know exactly where the clay and the sand deviation is throughout town.
I think that's really important. I've been seduced by the geophysical technique that would be a quick fix to that problem. So I think, oh yeah, we could do that. That's doable. That's technologically doable, and it could be done quickly. Just requires lots of money. So I think that would be my top priority, would be to figure out what the real boundaries are between those things, because that will help you decide those areas that you really have to protect. That you really have to protect it. And I think you shouldn't be based just on zone 2s, because the clay is there to help you. So take advantage of it.
Okay, Allison, we need $500,000.
Well, so I'm just thinking, I know you said mapping is dead, but like, how much would it cost if we paid someone to just like
So
go
here's-
out and do it?
Yeah,
Walk the,
Yeah.
Allison, here's the problem. You can't find anybody to do it.
Well, so
That is the big problem.
if we could, it's like feasible then?
But yes, it's feasible, and
How many
for many
students?
years, the 5 college geology group, all of the faculty from 5 college geology departments get together once a month. Well, the chairs get together once a month, talk about projects, and there's been a lot of discussion over the years about the fact that Mount Tom Quad, which has some classic geology in it, was never mapped. Most of those geologists don't care about the superficial stuff that we care about, but that was part of it too. And we've got lots of students, and they're really smart, and they can do really good work. And our institutions have money to support them working in the summer. So really, it needs us to be able to strong arm some faculty to supervise those students.
well, and I'll also add that this just intersects. I was reading the Unlocking Housing Production Commission report again today for work, and I was reminded about how the state is really pushing to figure out those tensions between environmental conservation and this housing abundance that they're really trying to push for. And I definitely think that a project like this would be very well within the priorities that the state is trying to push. So I think that we have a political tailwind in that way too, hopefully.
you have a ballpark estimate of what it would cost
Mhm.
the city for that effort? I mean, I get the convincing the faculty.
It would
Piece
cost
of
the
it.
city nothing.
Okay, so we wouldn't have to contribute. Okay.
If you went the route, a better route, the next better route is to get some graduate students from UMass to do it. Then you'd have money, you'd have to put on the table, which would be for the grad students. You'd have to pay
Right.
their time.
Externship.
So,
probably,
yeah,
Right.
Yeah, an RA essentially.
Yeah.
And the university will try to steal some tuition money out of that.
I benefited from that.
So,
Didn't
so,
we all?
so there, I think there are, well, I know there are ways to do it.
Yeah.
That way, you know, the problem with that way is you don't have, if we have undergraduates do it, it doesn't cost you a dime. The problem is you got to get it done.
Right.
And
Yeah.
you know,
Enough
there's a filter that students go through, and some will do great work on it and some won't.
Yeah.
And so that's, you don't, if you out and hire a company, they're gonna produce. If you try to get students to do, they might produce some really great work, but then you might not do so.
How far down do you have to go to get a good sample? To
Oh, it's not just about digging holes. It's about reading the landscape. And we have LiDAR. Oh my God. Oh my God. What a huge difference that makes. We have LiDAR. So as geomorphologists, we study the landscape and we can predict what's in the subsurface. We have to go and check place to place, but it's a combination of those things. It's a skill.
So how long would that take if you had a team of, say,
The summer,
5 people?
Summer.
A summer, at meaning
maybe 2.
2 months?
Yeah, if you're doing it with undergraduates, the surf program is 2 months.
And that could
Plus,
be
they're
done in
gonna
2 months?
spend their senior year writing up and doing the mapping, and it'd be an honors thesis.
But, so they could do the work, they could
Yeah,
do the
the
work. in 2
field work
months.
would have to be done, for the most part in the summer, they'd be doing some throughout the non-snow period.
And graduate students, though, you were saying are a better option.
Graduate students are a better option,
I vote for graduates.
but
I
I'll
get
have to tell you that you'll be hard pressed to find any graduate students to do geologic mapping. And I quite frankly won't advise any graduate students to do that as their thesis. It's a dead end.
But if we package it as this sexy housing density, environmental conservation project,
That would help a lot.
maybe that would be
And I
interesting.
completely agree that this project potentially has ramifications beyond Easthampton.
Yeah.
And therefore, Easthampton can be the model
Yeah.
that everybody else is based on.
I agree.
That's our general goal in general, is that we're the model everyone else is based on.
It could be like integrative learning with a housing student, graduate student, and then they could,
Yeah,
Put it
well, no, you
together.
could do that.
Yeah,
That would be
integrative.
great.
interdisciplinary, yeah.
Oh, absolutely. Get some, you get much easier to get students to look at water quality issues, those kinds of things. Answer some of those questions about what do people do on their lawn besides the impermeable area? What is out there now? They could go out and do samples. That wouldn't be a problem getting students to do that.
But in Massachusetts, you can't regulate for that, so you could know it, but then I guess you
But
could
it might
factor it
inform,
in.
it might
Yeah.
inform your zoning decisions.
What do you mean you can't regulate that?
You can't tell me I can't use something on my lawn.
It could be an interesting education opportunity, though, for the neighborhoods on the aquifer to better understand the implications of using fertilizer or whatever on their properties. I mean, I think people don't think about it really as much, you know, and it,
So we could have a project where students go out and put lysimeters in and collect the water that's infiltrating down through the lawn and do a chemical analysis and tell them all the carcinogens there.
We could start with Nonotuck Park and the athletic fields.
Yeah.
Project.
Yes.
So it sounds like, and correct me if I'm wrong, you've overseen some of these projects where students are helping with municipalities do this kind of work.
Yes.
In your experience, what does that process look like in terms of getting it started? What sort of, like, does the city need to come up with the terms of an MOU, or like, how do we start that process? Because it sounds like it's something people are interested
So
in.
what I always did is I wanted to see the water department. And they were always extremely supportive. I think Mike let me pump the Maloney well for like 3 or 4 days straight. I bought 250 gallons of diesel fuel, and we ran the well for as long as we had fuel. So it is that grassroots kind of thing that happens. So I've done lots of those kinds of projects. I also did a project, my groundwater class did a project at Westover, looking at some of the contamination issues at Westover. And we actually, the college, we had to sign a contract with the Air Force. Everybody had to get little badges to go on the thing. And that was a much more formal process. It was a good process. I only did it once because it was every weekend of the semester was in the field. But in the end, the students gave a report, and it was televised on, we had something like this televised on Channel 40, and the Air Force flew in their top groundwater people to critique the undergraduates' presentation.
That's cool. So you mentioned the chairs of the different departments coming together. Is it going to them and talking about like this opportunity? Or is it finding faculty in each of the universities? Because you're saying grassroots. It's like trying to.
Yeah. So I've been retired for 5 years. I still know what's going on in my own department, but really not in the 5 college venue too much. A little bit, but it requires faculty who are willing to devote their time to doing it. And like the problem for Smith right now is that us old guys have retired, and there's a whole bunch of young, new faculty. They shouldn't be doing this. They have to get their publications out if they're going to get tenured. This is not going to get them tenured. I'm going to advise them, don't get involved in this. It's going to suck all your time. It's great for the students. It's great for education, but it's not great for your career. So that's a bit of a problem. Once they're tenured, then they have the flexibility to do these things. But you know, it's a huge time sink. So it's hard to find right now. It's really hard to find faculty to do it. Maybe it's a good thing because research funds are drying up.
Mm-hmm.
So they can't get any grants. They can't do the sexy research. They'll have to do something like this.
we're gonna make it so sexy.
Yeah, I think packaging it sort of this, tension, this emerging cultural tension. And it's not just housing, it's battery energy storage. It's like, there's a lot of things
But
that,
the research is like hard science, right?
Mhm.
Like
Yeah.
the students would need to be versed in like hard science.
Are there no consulting firms that are capable to do this?
Oh, there are plenty of them, I think, that they can do this. But
How expensive are they?
It'll cost $500,000.
So that's for the,
That's for the
that's for the-
geophysical.
yeah.
But I'm involved in a watershed study for a lake in New Hampshire right now, and we hired a consulting engineering firm. It's costing $120,000 for a 2-year study. You know, they're kind of narrowly focused on their interest, which is in, cyanobacteria. That's really what they're interested in. And that's, so I'm an old acid rain guy, and, I have data from 1980 on this lake, and I'm not into that. But so can you find an engineering firm to do it? I'm sure you could. But it would be very expensive, and you'd have to have a very clear plan. I think you're better off getting the local institutions involved. And I think that maybe, maybe you want to go more direct to the environmental scientists and the social scientists to try to see if you can get those people. Those people will be more likely to be interested in this, and then they can suck in some other faculty.
But to my point, like the social sciences, are they gonna have the skill set to do this kind of work?
I think that if you get them involved, they will get other people involved. They'll get their colleagues involved. It's better for them to get some of my new colleagues involved than for me to try to do it.
So what it would be the social science plan for that? Like why, or planning?
Planning is a social science. Yeah.
Oh, okay.
So it seems like a next step would be perhaps together kind of figure out a scope. Because if we're going to shop it around, we need to really know what we are asking for. And I think we would need like both committees' expertise to kind of figure out what we need. And so maybe that's what we do next, is kind of start thinking about a scope so that then we can figure out who we want to go entice with it.
Because I mean, I'll just speak from experience at work. I mean, we're competing with many more people on every single RFP that we apply to these days because of how the economy is. So if we
Do a paid thing.
Yeah, and if we put out an RFP and saw what bids we got, I don't think that would be terrible. I will also say that I do prefer engaging with the local educational institution or something. Like I benefited from getting to do grad projects for the MMA and stuff like that. So I would definitely prefer that avenue. But if it sounds like it'll be rocky getting to that place. I also think there's nothing wrong with putting out an RFP. I'd imagine it wouldn't.
I don't want to be too negative about getting the academic institutions to do it. I can see it happening. It's just sometimes hard.
Well, we could even put out
But
like
I
an
think you
LOI.
guys,
Like just
if you put together a plan, you could shop it around, and you might definitely get some students to be interested.
Plus we have a couple of people here who have benefited from the program. So having had that experience yourself, you're in a good position to be able to talk to other people about why it would be good for them.
I don't think it's a problem getting students.
Right.
It's getting the faculty.
faculty. Okay.
The students will jump at this. And they'll see, our students will quickly see what the benefits are, and they'll be really attracted to this because it's more practical, using, better than studying some esoteric problem in geology. It would be doing something that has real community impact.
Field work.
Would make them much more excited.
The Conway School students have like great skills for this, because they're always looking for projects.
Yeah, I don't have any experience with them, so I can't say.
Really,
Patty, I don't know if you do.
landscape, yeah, artists.
Like design, yeah.
Still, landscaping design, you need to know something about the soils that you're working with.
All right, well, I'm aware of the time. Thank you, Bob. I think this was
Seriously.
Thank you, Bob.
so
Yes.
informative. I really appreciate the expertise. And I think we're all have the same goal in mind. We just need to figure out how to, you know, move this along in a way that protects all of our interests and protects the aquifer. And I think it's just going to take longer. I'm a little impatient, so I'm just going to temper my expectations about how fast we move on these things, and that's totally fine.
Well, I would encourage you to think about this as sort of a model thing.
Yeah.
And because it's going to be not just Easthampton, you're going to apply it in lots of different other places.
Southampton.
It might be worth the extra time that we're going to require, and maybe we can get, you know, if we can find a technique that will help with the clay, because we see that as important in a way that people haven't thought about it being important. You know, now it's going to affect where we develop and how we develop, and gosh, the geophysicists probably have never thought about that.
I also don't think it's only for housing. It's like
Yeah.
the city's talking about a potential senior center, and
Yeah.
like that this kind of work should definitely inform where we're citing large developments. And
It's
also
also
another thing that
years
he's trying to
tonight, I've been thinking about, because I'm going for another MVP grant.
That's what we were just talking about over here.
And the deadlines, they just issued the RFP. They're not putting a lot of notice out there because the portal's messed up. They're trying to fix it. But the deadline's March 20th. And I've been thinking like, because I can't attach like a huge sum to, you know, there's a couple of things I wanted to explore. One was, you know, population shifts. Like what is future demand really going to be? Because we're seeing declines in the current, you know, the current projections,
Right.
but there's like east-west rail, there's potential for climate migration. So is there a way we can start to sort of create some scenarios around that? And could we attach a piece that is, you know, deploying this intelligence about the increasing demands on these areas that are so developable, to finding the right spots and what uses might be best? But it would have to be not like a $500,000 piece, because that would never fly.
Right.
Yeah, but if we could give it shape in some way, and we were starting to explore what USGS might have done, but we kind of hit a wall with that so far, right?
So the Aeromag survey, that was the USGS gave mostly Massachusetts, but some Connecticut and some New Hampshire, Vermont, $750,000 for Aeromag survey in the Connecticut River Valley. It's the survey that it started in September of this past September. The survey that they were doing was mainly centered around pyrrhotite, which is a mineral that has gotten into concrete and causes your foundations to fall apart. But then they're flying these missions using the kind of technology that we would like to do for the clay. It's a similar technology, and I don't know how it's different. I suspect it's a different antenna system. I know they're flying fixed wing with a boom antenna on the tail. And what I think we need is helicopter with a suspended 30-foot diameter antenna. So I'm not sure that they're comparable, but I initially thought, oh, they've already flown it. We just have to get the data and we can process it. But I don't think that's the case. I'm still trying to get Brian. He hasn't responded to my last email. So I'm still trying to figure out what it's actually done. But that's a kind of program that if we went to them, or you went to them, and you said, you know, this is what we're trying to do, and we need this technology, this Aeromag technology to find the clay, and this is why it's so important. In the past, survey would perhaps come up with the money. You know, that and do it as a test to see, oh, can we do this kind of work? And they might even do it just to get it done. Because they've done that. It's a different world today, so I'm not sure that would, but I think those are the kinds of things. So if Patty could get a little money to do a little bit, that gets you started. And that's something you say, well, look, we've already got a little bit of seed money doing this. Now we need this. And well, okay, so someone else, you might entice someone to other forces to give money to expand this.
Would it help if we were coordinated with, like Southampton or Hadley that also shares the same concerns?
Well, I think
How
these
different?
trends and pressures for, finding more places for housing, for, all the battery energy storage, solar, like there's a lot of pressures. And I think we could articulate it without complicating it right now, because I think to engage other communities and have them be part of it, and working with drinking water suppliers in every community. And I wanted to tell you that we're having a roundtable tomorrow morning. You asked about the climate impacts, and Danielle from Dave Bout's lab is going to be contributing a whole conversation around sort of what future are we planning for in drinking water. But I know it's late in terms of notifying you, but it might be of interest.
Yeah, when is it tomorrow?
Tomorrow, 9:30 to 12 at the South Hadley Public Library. But I think like this piece of it, I think the simpler it stays, I think the better.
I was just thinking a larger area as opposed to just Easthampton, because obviously that's.
But I think you can,
the water is-
you can sell it by, okay, we're doing this little section, but the aquifer was built the same way everywhere.
Yeah,
So when we learn what is critical here, we may be able to apply it there more easily. We may find that we may be able to correlate various other things that allow us to better estimate where the clay is or something like that.
All right, I think we have some next steps in terms of drafting a scope so that we can, that seems so easy. That we can, share with each other and kind of figure out, and then figure out how to move it forward. Maybe share some with you, Patty, for this grant that's due, and yeah. Okay.
Do we want to set the intention to have another joint meeting in a few months, sometime in the spring?
Yeah,
April or
does that
something?
make sense? April, maybe, March or April?
I don't care.
Yeah. Okay.
Maybe March, if it's due in.
It's March 20th.
Oh, yeah, so
March
maybe
20th.
hopefully March.
Early March.
End of February, early March.
Let's see. Do you all have a regular meeting time?
Not really.
So we would meet at the end of February, but that might not, I don't know if that's enough time. It's actually like February.
Say, the end of March. It's not too long.
Well, we just, grant she was talking about the deadline's March 20th.
Could we meet like first week of March? Like March 5th, which is a Thursday
Yeah, that would work for me. The other
for you?
Tuesday, Wednesday are both full. And we have that public hearing.
Same time, 6 o'clock.
Yeah, 6 o'clock. Hearing the planning board.
With the planning board for those sections 1 through 4.
Oh, it's on Tuesday, March 3rd?
Yes.
Yes.
Well, we just confirmed it today, so
Okay.
I should have let you know.
All right, that's fine. That's good. All right. Yeah, so we'll do Thursday, March 5th at 6.
That's 6, okay.
Thanks, everybody. Yes, because I have a housing partnership question also.
Can I get your email so I can send you that?
All right, I am gonna stop the recording.
This government meeting is brought to you by Eastworks and our local cable subscribers.